Hey there, so this is my research proposal. I proposed an experiment on caffeine because that runs my world, so let's get into it. This is an investigation of enhanced productivity properties of caffeine, specifically memory and problem solving within the workforce. So productivity can be understood via improved memory and enhanced problem solving. Productivity is a concept of quality and efficient work behaviors. So heightened memory can assist with productivity based on quicker and better work outcomes, and memory can lead to higher quality of work. So productivity basically is just a way to understand workplace behaviors, and caffeine can be understood with productivity based on memory and problem solving. So that's how we interlink caffeine to productivity in the workforce, is with memory and problem solving. The research question and hypotheses are as follows. So first, we propose that 200 milligrams of caffeine will create a positive change in memory and problem solving. Predominantly, caffeine will be the benefiting of like group A, which is the experimental group, and the values of pre-test and post-test assessments. So we'll be doing a pre-test and a post-test assessment for both memory and problem solving. Group C is going to be our baseline group. That's going to be the group that gets water, no caffeine, and no decaf coffee drink. So we'll have 3 groups. They're going to have little to no difference in scores because there won't be any placebo effect, which is group B. Group B is going to get a decaffeinated drink. That way it's a coffee drink, but there's no caffeine in it. That's where we're going to control for placebo effects. We do predict that there might be a slight increase in scores just because of that placebo effect for group B. Also, there's a prediction that the relationship between score values of the caffeine levels will create a significant interaction. The most evident difference in the relationship will be independent variables to be predicted to be 200 milligrams of caffeine levels. So specifically, group A is going to have a notable increase in scores compared to B and C. So the null hypothesis is there is no change in memory and problem solving abilities with the presence of caffeine. And that is how we're going to do that experiment. So for our literature review with research, we found that 85% of Americans consuming an average of 400 milligrams of caffeine on a daily basis. So this experiment is going to just go with 200 milligrams of caffeine. I myself drink more than 400 milligrams. I know the average is 400 milligrams. But I don't know if the participants in my study are going to be caffeine naive or not, as in I don't know if they've had caffeine a lot in their life, so I'm not trying to over-caffeinate anyone in the experiment. So with the average being 400, we'll half that for the participants into 200 milligrams for the experiment. There is research that caffeine does increase alertness, learning is stimulated, there's a decreased reaction time, which means people move faster and react faster. There's improved sensory motor skills, which go into that fast reaction time. There's increased, or I guess improved self-judgment, self-awareness. And there's also increased performance, positive moods, and concentration. That increase in performance and concentration is where the researcher, me, decided that there would be, in the hypotheses made, there would be, improvement on memory and problem solving because there is research to back increased performance and concentration. Low to moderate doses of caffeine significantly improve simple problem solving abilities, which also went into the 200 milligrams for the experiment. Low to moderate doses having that kind of effect on problem solving is what we're looking for. So we wanted to keep it low for the participants. The milligrams, we want to keep it low for the participants. We also want to see that problem solving increase. So that's where the 200 milligrams comes from, both of those items. Further on with this, current literature has inconsistent results with caffeine effect on executive functioning and memory. So it'll be interesting to see how memory plays out with this proposal. There's a variety of different findings with scholarly conversations going on regarding the effects of caffeine on memory. So this is a discrepancy that would, this proposal would close that gap in research a little bit better. The methods. So for participants, we wanted to use participants that were working age, since this is a focus on the workforce. So anyone 18 to 60 is where the participants should lie in age, just so that way the generalization of the participants is valid. We want to make sure that the participants in the study are equal to that of the workforce. We're going to use 75 participants in total, 25 for each group, the experimental group with the caffeine, placebo group with the decaf, and baseline with the water. We're using two different tests. So the Wechsler memory scale is going to be used for a pre-test and post-test to see the value difference in memory scores. And then the rapid assessment of problem solving is obviously going to be used for the problem solving pre-test and post-test to view the difference in scores pre-test and post-test for that. So those are the materials, along with obviously pen, paper. Water is going to be available for all participants, not just the water group, and other things like that. We'll have an office space and cubicles for participants, timers for researchers, all that good stuff. The data is collected with the pre-test and post-test, as we've been talking about. So we'll do a pre-test of the memory and the problem solving, and then we'll have the participants drink their coffee drink. So participants in group A will have 200 milligrams of an actual coffee drink. Group B is going to have a coffee drink that is decaffeinated, no caffeine involved. Group C is not going to have a coffee drink, they're going to have water. So they'll still use that same waiting period after we have the participants consume their coffee drink. There will be a 30-minute waiting period, so that way group A has time for that caffeine to take effect before they go into their post-test. Group B and C will also have the same waiting period, just to keep consistency across the board. We don't expect that anything will be like triggered in their brain during that waiting period. It's just to keep the experiment safe. So the post-test is where we're going to see the results, the values of the memory and the problem-solving scores change from the pre-test. This is where we're going to be looking. The change between pre-test and post-test, that value of change is going to be what we dictate our experiment data on. So the results of difference between pre-test and post-test is what we're looking at here. This is a controlled, randomized, double-blind, 2x3 mixed factorial quasi-experimental design. So it's controlled. It is randomized. The participants will be randomized based on their group that they go into. It's double-blind. The experimenters do not know, obviously, other than the water, but the experimenters do not know whether a group A or B, or they're giving them caffeine or decaf. So it'll be double-blind. It's a 2x3 mixed factorial. Independent variable is caffeine intake. The dependent variable will be the differences in scores of the pre-test and post-test for memory and problem solving. So these differences of scores for the assessments will be calculated by subtracting one from the other. We're going to subtract post-test from pre-test. So if there's a positive value there, that means the post-test had a higher value than the pre-test. There were more answers correct on the post-test than the pre-test. If the value is negative, that means that the participant scored better on the pre-test than the post-test. So that's going to go into effect with the negative value. The values are obtained from the different scores from the pre-test and post-test. So it's going to determine the changes in memory and problem-solving abilities based on the caffeine intake or the placebo effect or a baseline effect. So hypothetically, you know, this is made-up data, but we're going to use an ANOVA to process this. It's going to be caffeine levels as the independent variable, 3 different factors. One is the different values of pre-test, post-test, and memory, different values of pre-test, post-test, and problem solving, and then the total sum of all items. So if significant at 95% confidence intervals, it will be drawn about the different values of each group. There are 74 degrees of freedom with an alpha level of 0.05 and a clinically significant or critical value of P005. I'm sorry, P is 0.05, excuse me. So if we get significant results from this, that means the null hypothesis is rejected. There's a change in memory and problem-solving abilities with the presence of caffeine is what that can mean. So that would help us to fill the scholarly knowledge of workplace productivity and caffeine factors in the workplace. So it would help to understand memory, especially because there's a gap in memory knowledge or memory understanding with caffeine. It would also help to give more information about workplace behaviors with caffeine. So it helped to fill some scholarly gaps right there. Significant results might also mean that there is a decrease in memory and problem solving. So it can go one way or the other. If there is a decrease in memory and problem solving, especially a decrease in problem solving, since we do have scholarly knowledge right now that problem solving is increased with caffeine, a significant decrease result would lead to further investigation of the experiment for confounds and to make sure the experiment was set up correctly. And if it was set up correctly, that might lead to a new understanding of caffeine in the workplace as well. So that would be an interesting take on the experiment for sure. If we get non-significant results, Of course, we would want to still evaluate the experiment for confounds, but non-significant results would still create a new understanding in the workplace of caffeine in the workplace. So that would still be something to talk about, especially because if we got no significant results for problem solving with the knowledge that we have, the scholarly knowledge that we have currently, that would be interesting to see. And that'd be a new take on the knowledge that we currently have. So that would be something interesting as well. For future research, there's two different options that can go from here. An observational in-field study could be conducted to find more information about caffeine intake in the natural setting of the workplace. It'd be interesting to see if it's more of a social kind of aspect, or if people like myself exist out there where it is necessary for survival and productivity. So it would just give us more detail about worker behavior. And it could help us understand more about, by monitoring computers and pace of work, it could help us understand a little bit more about the effects of caffeine as well by having that raw data. Another study for future use is an inquiry into any non-significant results or those opposite results expected where it's significant decrease. If the experiment was set up correctly and we got non-significant or decreased problem-solving results, that would be very interesting to further investigate from there. So in conclusion, the implications of this study will provide more conclusive knowledge of caffeine's effects on productivity in the workplace, productivity being memory and problem solving. It would provide more decisive results on caffeine's effects on executive functioning and memory, which we have a lack of knowledge on currently in scholarly understanding. So just more concise knowledge of caffeine in workflow can assist in creating better work environments as well. So that's something to take into fact. Thanks so much. Have a great one. These are my references if you want to check it out. There's a good amount. So, all right. Have a good day.